Welcome to this video on the Introduction to Networking. We will cover the fundamentals of network addressing, focusing on both IPv4 and IPv6. IP addresses consist of two main parts, a network identifier and a host identifier. The network ID is like an area code, specifying a network section. The host ID is similar to a phone number, identifying a specific device within that section. This visual illustrates how IP addresses are structured across different classes. Class A uses 8 bits for the network and 24 bits for the host. Class B uses 16 bits for each, and Class C uses 24 bits for the network and 8 bits for the host. IPv4, introduced in 1983, is the original addressing system. It uses a 32-bit address scheme, allowing for over 4 billion unique addresses. IPv4 addresses are commonly displayed in decimal format, separated by dots into 4 octets. IPv4 addressing has 3 types. Unicast, which is a single sender to a single receiver. Broadcast, where the message goes to all devices in a network. And multicast, sending a message to a group of devices. Network devices have 3 primary identities: the physical address or MAC address, the logical address or IP address, and the host name, which is a recognizable label for human use. Here is an example of an IP address workstation, showing the host name, IP address, and MAC address, illustrating the 3 common identifiers. This table summarizes the characteristics of Class A, B, and C IPv4 addresses. It shows the range of the first octet, number of subnets, and number of hosts for each class. Classes D and E are also part of IPv4. Class D is reserved for multicasting, and Class E is set aside for experimental use. Class A is for large networks, like 10.0.0.0. Class B suits medium to large networks, exemplified by 192.168.1.0. Class C is for smaller networks, such as 192.168.2.0. The key difference between IPv4 and IPv6 is the address size. IPv4 uses a 32-bit address, while IPv6 uses a 128-bit address, providing a much larger address space. IPv6 addresses are 16 bytes long and use a hexadecimal format separated by colons, as illustrated here. IPv6 was developed to address the exhaustion of IPv4 addresses. As a 128-bit address, it offers a vastly larger address space than IPv4 and is displayed in hexadecimal format using colons. An IPv6 address can be simplified by omitting consecutive zeros. This example shows a full IPv6 address and its shortened version. To convert hexadecimal to binary, remember that each hex digit represents 4 binary digits. You can use a conversion table to find the corresponding 4-bit binary value for each hex digit. This table shows the decimal, binary, and hexadecimal equivalents for values from 0 to 15, which is essential for understanding IPv6 addressing.